Okay. Alrighty. Well, thank you for your patience, everybody. As you can see, unfortunately, a minute or two before the conference began, we had some technical difficulties. I'm now calling you from my phone. Thank heavens for modern technology, it allows us to do this. But in any case, welcome back to the 2020 West Region Cooperative Soil Survey Conference. My name is Dr. Colby Brungard. I'm Assistant Professor of Pedology at New Mexico State University, and I will continue to be the meeting host today. Today's conference will be organized into 4 sessions. Those sessions you can see on your on the program, and those 4 sessions although there's 4 sessions, all of those sessions will be held in this single Zoom meeting. Our first session today will be our student presentations. We'll then follow that with several technical presentations. The session following that will be committee reports, and then finally we'll close the meeting with an award session. Questions for the student presentations and the technical reports will happen similar to yesterday. Rather than ask questions of every speaker following their presentations, we have a dedicated question and answer period after all of the presenters have finished. If you do have a question for the speaker, please use the chat option to ask your question, and either I or David will be able to collate those questions, tabulate the questions for each speaker, and then read those questions back to the speaker during the question and answer session, and the presenter then can answer your questions at that time. For the student presentations, there's 2 very important things to know. The first is that these presentations will be rapid fire, meaning that the students will only have 5 minutes for the presentations. The second is that a cash award will be given for the best student presentation, which you will help choose. Following the conclusion of the final student presentation, a poll will show up on your screen. This poll will list the name and title of each student presentation. Please choose the single presentation that you thought was best. Because of the virtual format, we leave the decision of what defines best up to you, but options could include evaluating which student delivered the most intriguing, the most concise, or the clearest presentation. At the end of the individual committee reports, the poll will close and the student with the highest number of votes will be selected as the winner. I will then announce the student winner at the end of today's session, and then I'll be in contact with the student within a few days. I want to take a moment to thank everyone who contributed to the student awards. A total of $650 was donated for these awards. So let's go ahead and begin today's session, and we'll turn it over to the first student presenter. I won't go ahead to make this flow as smoothly as possible. When one student's presenter is done, I ask that the next presenter go ahead and just start their presentation. Thank you.
All right. Hello, everybody. Let me share my screen. And get the laser pointer out. All right. Hello, everybody. I'm Hunter Windsor. I'm a PhD student of Dr. Brungard's here at New Mexico State University. I work on creating a quantitative definition for land resource units. And in doing so, I am working on quantitatively defining soil systems. A catena is an ordered set of soils that are linked morphologically from stream center to an interstream divide. These link most of the soil forming factors together, which generates soils that are related to one another. A group of similar soil catenas is called a soil system. Here is a descriptive map of soil systems which exists for North Carolina. We would like to recreate this map quantitatively. Here's how we're doing it. First, we need to make a set of soil catenas for the state of North Carolina. To do that, we use the statistical language R. In R, the packages AQP and Soil Database allow us to query soil polygon data. The National Hydrographic Dataset provides streamlines, and Hydrologic Unit Code 10 watershed boundaries limit the processing extent. Next, we buffered the rivers to select all of the soil polygons that are river adjacent. Then we took each of the selected polygons and walked them uphill until reaching a local maximum. Here we can see what a single soil catena looks like. We saved the elevations, map unit polygon keys, and national map unit symbols. There were roughly 800,000 catenas for the state of North Carolina. You can take each of these soil catenas and plot them along with elevation to get a faux soil block diagram. This one specifically is made for the desert Southwest. The code to make these is on my website. Next, we took this soil system map and classified it. Then we overlaid the watershed with the catenas and classified the catenas based on their location on the classified soil system map. Currently, we are taking the classified individual catenas and are mining sets of soil patterns using an association rule mining approach with the intention of identifying standard catenas inside each one of the soil systems. Once soil systems are quantitatively defined in North Carolina, we hope to be able to use the same system in the desert Southwest via a trained but unsupervised classification system. Hopefully, it can be a useful definition for land resource units. So in summary, soil catenas can be generated from existing soil survey, elevation, and hydrographic data. Soil block diagrams can be created from catenas, and current work is focused on pattern analysis of soil catenas to classify them into soil systems. You can visit my website, soilsystems.org, for the R code. And that's it. Thank you very much.
Thank you, Hunter.
You're welcome.
I'm trying to find what I have up, but it's not coming up for some reason.
Okay, well, Chelsea, we can hear you, so not a problem.
Great.
Ah, there we go.
Okay, 1 second, because I need to optimize it. I apologize, it worked in the test.
Not a problem.
Oh gosh.
Chelsea, if you just hit the share screen button again.
Yep, I
And
just
then-
didn't have optimized
Okay.
when I clicked it the first time. So sorry, everyone.
Okay. You do see that window where you pick whatever screen you want, screen 1 or screen 2, correct?
I'm sorry, what did you say, Hunter?
Screen 1 or screen,
Hunter.
yeah, if you share your screen, is it screen 1 that you're seeing on that window?
Yes, hold on 1 minute. This is really embarrassing. Oh gosh. Should the next person go and I'll just go after them? I don't know why this is not popping up right now.
Sure,
That
will
works for
work.
me.
Yeah.
Okay, I will go next then. Thank you very much.
Hi, everyone. All right, can everyone hear me?
Yes, we can.
Awesome. Hi, my name is Jolene Weatherholt, and I'm going to be talking about my thesis work on soil water repellency responses to burn severity in the Pacific Northwest. And, where are we? Here we go. So soil water repellency is formed from hydrophobic compounds in organic litter. Think the waxy cuticle of pine needles that during a fire will vaporize into a gas and diffuse through soil pores. And as temperatures decrease down the horizon, those gases will condense and create a subsurface film that when water enters the system, it will hit this layer and create a slip point. And this will intensify erosion. So soil water repellency can actually occur naturally without fire as well through the leaching of these compounds over time. And this is going to alter that spatial pattern of water repellency post-fire. So we've seen in the literature that burn severity, burn temperature, and time greatly impacts spatial patterns of soil water repellency, which is seen on the right figure right here on the side. So this picture on the left is taken from chest height and shows the drastic range of soil conditions and soil burn severity classes found in such a small area. So this is going to also impact those complex spatial patterns of hydrophobicity responses. And so soil water repellency persistence compared to canopy and soil burn severity was sampled in 4 fires in 2018 that burned back in 2017 with the hopes of providing some form of predictive power of increased erosion risk for managers based on burn area emergency response team, soil burn severity maps, and field observations. And each burn perimeter actually encompassed a wide range of soil classifications, but each were unique at each fire. And so plots were chosen based on, so that the canopy burn severity would be a single variable over the entirety of the plot, but then specific subpoints were selected at 4 locations per plot to measure soil burn severity. And so at each of those 4 locations, we also measured water drop penetration time test. And so this is where at each location on this 10-centimeter soil core, we placed a water droplet, and if it could last for 5 seconds, it would be considered hydrophobic. And if it infiltrated, it would not be. And so from this, we ask, are there patterns of soil water repellency occurrence in the Pacific Northwest across different intensities of canopy and soil burn severity? And so then once we've established that we can see a pattern, can these measurements of soil and canopy burn severity be interchangeable to managers in the field? And so 2 of these fires we sampled in Oregon and Washington had an average of about 80% of unburned sampling points with that naturally occurring soil water repellency. So the y-axis here is the percent change from that unburned level. And we found that these sites average between these 2 fires, we can see that there is a canopy burn severity and soil burn severity difference. We can see that increase here. And so those 2 Montana fires that did not have naturally occurring unburned repellency also have the same pattern of increase. And so because of this, managers must prioritize limiting our fire behavior and our fire intensity to prevent increased erosion as we're seeing more fires, more intense fires on our forests. And so now I'm pulling out that soil burn severity percent change from our Washington State fire in North Peak. And we can see again this clear pattern of percent change compared to the unburned levels from low to high. And it's a really interesting process here. But now if we look at this same fire, but instead of using soil burn severity, if we take that canopy burn severity levels, we can see that that distribution is not there. We can see that that severe surface plot has had an extremely variable response compared to our soil burn severity. And that is due to our severe surface fire having such variable soil burn severity responses. And that's this bar right here. And so with having such intense soil burn severity responses, we're going to have that intensely different fire activity, and that's going to respond differently with soil water repellency on the ground. And so there are actually many ecosystem factors that attribute to soil water repellency, but to a manager, this is going to be extremely confusing. There's a lot of different things going on here. So can we take all of these different relationships of soil water repellency and simplify it down into 4 different variables? And so those variables are the burn area emergency response team map products. That's going to be weather patterns from Prism Climate Group, Landsat satellite data imagery for vegetation density, both pre pre and post-fire, and especially those soil classifications from parent material to organic matter content from the SURGO data. And this is going to increase managers' predictive power of intensified erosion risk as we pursue this research. And as soil survey data becomes more finely identified, we will be able to more accurately predict soil factors on a finer scale in a way that's more beneficial to managers. And so as we're seeing more fires enter the ecosystem, especially in the Pacific Northwest, this information will really help work towards soil and forest health. Great, thank you guys for your time, and I hope you have a great one. Thanks.
Thank you, Jolene.
Okay, I'm back, and here we go. Good afternoon, everyone. My name is Chelsea Dubal. I'm a PhD candidate in soil science at the University of Wyoming. My expected graduation date is May 2021. Here's my email information below if you'd like to contact me after the meeting. Today, we're going to be talking about a portion of my dissertation research focused on investigating FES formation in semi-arid wetlands. I'd like to take a moment to thank my NRCS collaborators in New Mexico, California, Utah, and Wyoming, as well as Colorado. Without them, this project would not be made possible. So to begin, I'd like to set the scene for FES formation. FES formation occurs exclusively under strongly reducing conditions, or this dotted area you see here. This occurs further down on the redox ladder, where we have lower redox potentials, and microbes are utilizing Fe3 and sulfate as their terminal electron acceptors to carry out their microbial processes, reducing them to Fe2 and sulfide. Under these strongly reducing conditions, we also need anaerobic conditions present, so we have that, as well as a capable microbial community, a carbon source, an iron source, and a sulfur source present. If these are present in the soil, we could see dark gray to black insoluble features forming in the soil morphology, or FES. This phenomenon is common across coastal systems. However, it's less acknowledged in semi-arid and arid wetlands. However, they do exist. This is where our project comes in. So our goal with this research was to investigate the formation and expression of FES to get a baseline understanding of how and where these properties form, and to explore the potential for FES to improve hydric soils identification in the semi-arid and arid US. So in order to do this, we established paired upland and wetland sites in California, New Mexico, Utah, and Wyoming. We assessed the soil morphology, saw if any field indicators of hydric soils were applicable, and looked into the anaerobic conditions via iris films. So to quickly go through this, these results here, across all wetland sites, we saw FES in the morphology, and it was expressed ranging from 1 to 100% in the morphology. So FES was present. Also present in the morphology were iron concentrations and depletions. However, those were not present in high enough abundance or contrast that met any field indicators of hydric soils, with the exception of Utah, which met F2, which is a glade matrix. And that was because of our BG2 and our BG3 meeting a color on the GLA1 page. That was regardless of redoxomorphic features. This is the point where I should mention that FES is not incorporated in the field indicator guide in any language or indicator as it presently stands. So we figured out that we have 3 out of 4 of these soils that present a problematic situation. So we wanted to look further into those anaerobic conditions to potentially employ the hydric soils technical standard to quantify if in fact these soils met the definition of a hydric soil. So to do this, we used 5 iris films coated with an iron oxide paint, and they were deployed for in situ for 30 days. If exposed to reducing conditions, that orange Fe3 color changes to white as Fe2 becomes Fe3 is reduced to Fe2, and Fe2 is soluble and stripped off of the film. Alternatively, we can see black precipitating on the films under strongly reducing conditions if sulfides are present in the soil and are reacting with the Fe3 on the film. Now, the current hydric soils technical standard requires 30% iron reduction, so a white color change, in the upper 15 centimeters for a zone that ranges 15 centimeters long in order to constitute anaerobic conditions are present. So that's 3 out of 5 tubes or films. And we only saw this at our California and New Mexico sites. However, a paper by Vaughn et al., published in 2016, suggests and recommends that if 2% FES precipitates on these iris films, that is representative of anaerobic conditions as well. And all 4 sites met that for every single iris film in this study. So a pretty interesting finding. However, I should note that only applies to the films and not the soil morphology. So moving forth with this study, we just would like to acknowledge that FES are important and often overlooked morphological features. They're often misunderstood for other properties such as manganese oxides, organic matter or charcoal that can be dark. A recent paper published in SSSAJ suggests a few very easy, inexpensive tests that can help differentiate between the 4. We'd like to note that these properties are applicable and present in other states, regions, system types that are rich in sulfur, so keep your eyes peeled. We've seen them as far north as Alaska and obviously all along the coast. For this reason, and some of our findings in our ongoing research, we'd like to propose the incorporation of FES into the field indicator guide to improve hydric soil ID in the semi-arid and arid Western United States and beyond. And I'd just like to note, I know I'm short on time here, that we need to further investigate the biogeochemistry and expression of FES, particularly under wet and dry cycles, considering impacts of climate change moving forth. With that, I'll thank you for your time and take any questions at the end.
Thank you, Chelsea.
All right, can everyone hear me all right?
Yes, we can.
All right, so hi everyone, I'm Kean Speck, and I'm an undergraduate at the University of Montana, and I'm currently studying ecosystem science and restoration. I'm also a soil science pathways intern with the Missoula Soil Survey Office, and the project I will be talking about today is part of my work with the Soil Survey. I also wanted to thank everyone for attending this presentation. I know this conference is a little bit of a different format than we're used to, but I hope that today you'll all learn something about VNIR technology and appreciate the importance of understanding soil organic carbon. Now, soil organic carbon is an essential soil property which greatly influences factors such as fertility, stability, and water holding capacity. Unfortunately, the common methods that we have for estimating soil organic carbon are expensive, destructive, and oftentimes time-consuming. The limitations of our common methods mean that soil samples are rarely taken during the course of soil survey field campaigns, and we are often left with an incomplete picture of soil organic carbon across the landscape. By contrast, visible near-infrared technology, or VNIR, is a cost-effective method to estimate soil organic carbon without destroying the soil sample. It works by measuring the light emitted from a sample and correlating those wavelengths to specific soil constituents. Scans are simple and easy to make, as well as extremely fast. In fact, VNIR is much like the rapid fire presentation I'm giving today. It is a powerful tool that can quickly tell us important information about critical soil properties. Now, the purpose of our study was to evaluate how effectively VNIR technology can predict local soil organic carbon here in Western Montana, and also to create the technical documentation needed to assist and incentivize soil survey offices in using VNIR technology. To do this, we built a partial least squares regression model using soil organic carbon data from the University of Idaho Soil Characterization Lab, and we combine that with our own VNIR scans. So these pictures I have here on the left, this is a typical wave band from a VNIR scan, actually multiple wave bands. And then here on the right are some of the points where we gathered these soil samples. So mostly in Western Montana, And there actually are some points in Idaho as well. Now, our model works by splitting the data into two parts. One part is to train the model using real lab data, and the other part is to test how well that model performs. Our results show that VNIR is capable of accurately predicting soil organic carbon. So both the train and the test data sets performed with high R-squared values, 64 and 69 respectively. And then we had an RPD value, or residual prediction deviation value, of 1.79. And what that basically shows is that our predicted values are very close to our measured values. We also created technical documentation that guides the reader through building their own model using R coding software. And in the Missoula Soil Survey Office, we've noticed a greater incentive to gather soil samples due to our ability to make almost immediate use of them. So our study is significant because first, it shows that VNIR technology is applicable for use in local soil survey offices. And additionally, we are one of the first offices in Montana to integrate VNIR technology on this scale. In the future, we plan to create similar models to predict soil properties such as water holding capacity, or pH. And we also hope to acquire instruments capable of more intense analysis, such as mid-infrared machines and X-ray. And we actually just got the go-ahead to get a mid-infrared, so that's pretty exciting. We also hope to continue to create more technical documentation to assist other offices interested in utilizing VNIR. And it's our hope that the soil survey offices can integrate this technology into their local areas in order to provide better information about soil organic carbon, for instance, if a forest burns and there's water repellency. So that's my presentation. I want to thank you guys for listening. And if you have any questions, please feel free to email me or Jay. So thank you.
Thank you, Kian.
Yeah.
Okay.
Michael, we
Hello,
can hear
everyone.
you, and we can see you, and we can hear your screen, so you're good.
Okay. Hello, everyone. My name is Michael Sousa. I'm a master's student from the University of Minnesota, and today I'm going to talk to you guys a little bit about cost-constrained CLHS for remote sampling. Okay, so before we talk about the cost constraints, let's just go over CLHS quickly. So condition latent hypercube sampling is an algorithm that's designed to assist in locating sampling points in an area that's yet to be sampled or that has limited data. Basically, it uses a user inputted raster data to attempt to suggest areas that would capture the greatest variability. Most of the time, these rasters are soils related, like formation or development. So think DEM, aspect, satellite imagery, topographic wetness, something like that. And additionally, a cost raster can be used to further constrain the model. So here it takes into account how much it's going to cost to get to these points and hopefully can maximize and get you the most bang for your buck. Okay, so our specific problem is in the YK Delta. The project area is roughly 20 million acres, and it's exceptionally challenging landscape to gather soils data with traditional methods. Basically, there's multiple methods of transportation throughout this area. One of them is not driving on roads. There's very few out there. So just to get you guys a little bit of an idea of what it looks like, there's a lot of winding rivers and a lot of swampy lowlands. Okay, so the cost raster. So the cost raster is going to be inclusive, and it's going to include all of the possible methods of transportation in the area, including a float plane, a riverboat, a helicopter, and then walking out of villages a certain distance. And then the functions will represent the cost spatially for each of these methods. And then one final raster will be created combining all of these methods and taking the lowest value. Okay, so this is the float plane cost raster. We made this by taking a shapefile and filtering it based on water body size per recommendation from the float plane pilot. They need a certain surface area lake to take off and land. And then we applied a function that shows the cost based on distance from the place the planes take off. And that's also adjusted by how fast the plane can fly and the hourly cost. Next one is a helicopter cost raster. This is pretty similar. The major difference you'll notice here is that there's minimum daily charges for the helicopter. So these circles are 150-mile radius. It's really expensive to use helicopters in Alaska. $4,000 is the minimum cost here, and just a small portion of the study area is outside of that. Riverboat, and I can zoom in here a little bit. We digitized some major rivers outside of these two major cities and calculated the cost based on river miles, the velocity of the boat, and the cost per hour. And then last but not least, walking out of villages on foot. So these were calculated just using current fares or air prices out of Bethel to get to these villages, and then they were buffered about 2 miles to what you would consider like an area that you could sample like in a day. Okay, so the combination is pretty cool. It shows all the different modes of transport. In addition to, you guys can't see it on here, but if you actually had this in your GIS and you clicked on a cell, I tagged each one of the methods so you could see where they came from. So if you clicked on a cell, you would get a tag of like 0.3, and that would tell you it's a riverboat out of St. Mary's. So this is nice because some of these points that are really far away from these city centers, you would expect to be very expensive, but there is a lake large enough that a float plane can land on that you could get to. So we haven't implemented this yet into a CLHS. We hope to soon and be able to have those points compared against points where there wasn't cost constraints. We just have like this very unique problem of this large area with different modes of transportation. It's not immediately obvious which method is the cheapest or like the best bang for your buck. So we hope that this workflow can be further used by other land managers in areas like this that also have different methods, and they kind of don't know where to start as far as selecting sampling points. So again, my name is Michael Sousa. If you have questions, feel free to email me or just put them in the chat, and thank you for your time.
Thank you, Michael.
Okay, can you hear me?
Yes, we can.
All right, outstanding. Great, so my name is Ryan Hodges and I'm a graduate student at Utah State University. And I want to share with you a little bit about really an introduction to the research I'm doing on the island of Maui, and share with you a little bit about the soil order diversity of the island. So this is the island of Maui here. If you follow my cursor, this is the summit of Haleakala at 10,023 feet. So when I started the program, my advisor was generous and allowed me to kind of develop my own research project and question. And it got me really excited because being from Oahu, I was really aware of Hawaii's soil diversity, and I knew of its research potential. And so in the 2000s, there have actually been quite a bit of groundbreaking research on the Big Island of Hawaii, and particularly the Kohala Peninsula, looking at the effects of climate and precipitation on soil formation. And Maui, the second youngest island in the Hawaiian chain to that of the Big Island, is rich in soil diversity in comparison on the soil order level. So I want to talk to you a little bit about that today. So the island of Maui receives anywhere between 11 inches and 400 inches in mean annual precipitation. And so based on previous research and findings, we wanted to divide our site selections and sampling based upon a division of these mean annual precipitation ranges. So I've provided that in the upper left-hand corner. The first at negative or less than 400 millimeters, 400 to 700, 700 to 1400, and greater than 1400 millimeters in mean annual precipitation. So we've sampled at least 3 sites between each precipitation range, all on a generally westward aspect on minimal slopes, so less than 5%, and they're all above the same basalt formation. And so figure 1 on the left shows those defined mean annual precipitation ranges. And all of our sites are the sites in triangles, and the ones in yellow are from last year. Red is sites we sampled in March of this year, and the sites in orange in figure 1 are sites that we hope to sample from in the future. I've also displayed some NRCS sites, which are the black squares that have been sampled anywhere between 1963 and 1999. And so hopefully those will be able to provide some useful data for our spatial data analyses in the future. Figure 2 on the right is really neat. It really shows the soil order diversity of Maui. And, you know, due to that large precipitation gradient and variability in volcanic ash deposition. So Maui has 8 soil orders. All of our sites are located on 6 of those soil orders, with the exceptions of histosols and entosols due to our parent material limitation. And what makes Maui really neat is that it provides a practical application for understanding the effects of soil diversity caused by its broad precipitation gradient and variability in ash deposition. Oh, it's going the wrong way. So this next slide shows 2 small scale sequences of some sites that we have and would like to sample from, both of which receive similar amount in mean annual precipitation, but may vary in whether or not they've received or have been influenced by volcanic ash. And so figure 3 on the left is a small sequence. The upper site, which is the red triangle, is a site we sampled from in March, classified is on a soil classified as a tauroxic haplostall. And the center site in blue is classified as anoxic distrostept, and the southerly site is on a soil classified as an andic paleohumult. Looking at figure 4 on the right is what I call a wet sequence for our study area, and it spans 2 humults and hopefully a site that we would like to sample on a UDAND. So really, you know, it kind of addresses a couple of our objectives, and that's to measure the degree of weathering of these sites, as well as kind of propose how superficial ash deposition affects above basalt affects the weathering stage and direction of these soils. And so with that being said, I want to thank you for your time, and I've got my email address provided at the bottom if you'd like to contact me with any additional questions. Thanks.
Thank you, Ryan.
You're welcome.
Okay. We now have a few minutes for questions for all of the students. There's one question that I see here right now for Kian, asking, you mentioned that you had a website. Can you tell me what website that was? What is the website?
Yeah, I may have misspoken. I actually don't have a website, but we do have like technical documentation. So if anyone wants that, just shoot me your email and I can email you kind of what we have worked on so far.
Thanks. Ryan, I had a question for you. What was the most surprising thing that you found about the soils of Hawaii that you've sampled so far?
Definitely one of the most surprising things is we've sampled 16 from 16 sites so far, and we've dug down to a meter at each site. And well, you know, what's really unique about all these soils, although they're on the same basalt lava flow, you know, this basalt formation itself spans about 500,000 years. And so, you know, obviously some of these soils are going to be closer to the peak of the volcano, and those that are further, the ones that are further are going to be probably weathered a lot more than the ones closer to the summit, you know, regardless of whether or not that they're on the same flow or not. So even if, yeah, really just the amount of difference, the you know, in morphology and color and depth of these soils, even though, you know, it's just from the same flow, you know, just how stark these differences are based on the distance from the summit, as well as how much precipitation these soils are getting. You know, and even the parent material, we collect rock samples at each pit, and even the rock samples are very different.
Okay. Well, thank you very much.
Yeah.
If there are further questions, if the group has additional questions for the student presenters, I encourage you to use the chat option to continue to ask those questions. That concludes our student presentations. Very shortly, you should have a poll appear on your screen, and that poll will remain open until about roughly 4:20, 4:30 today. Please use that poll to provide to choose the student that gave the best presentation today, and then we'll show the results later.
Kobe, there is a question for Ryan actually just now.
Okay, Ryan, it looks like there's one more question here. It says, are any of your current or future sample sites on public lands? And do you see any initial insights for land manager decisions on those in Hawaii?
Yeah, so I totally glossed over what I wanted to say about that as far as land management. And so most of the sites that I sampled on were on land that was owned by ranch owners. And the majority of the study area belongs to, a very short list of ranches. And so they have been the most helpful as far as gaining access to their property, just due to their support in being able to manage these lands. And there's another site that I sampled from that belongs to a new farming company called Mahi Pono, which has purchased about 41,000 acres of old sugarcane land. So, they too are trying to transform this old, sugarcane lands, water demanding sugarcane into diversified crops for the public and for Hawaii. And so, I think people in Hawaii are eager to move towards some degree of self-sustainability. So I think there's a general support for access to land on the island. And so, that was also one of the challenges with selecting sites is I wasn't able to access private property. And, generally people are pretty reserved in Hawaii about letting people access their land to dig a big hole. So, but for the most part, yeah, it's been pretty supportive.
Ryan, thank you so much for your answer. I apologize. I need to cut it a little bit short so we can stay a little bit closer to our schedule. I do apologize.
No problem.
Okay. So for those of you that are working on the poll, if you cast your result, and then if you want that little box to go away, just click on the X in the upper corner and that box should go away for you. So we're now going to move on to the next portion of our to session 5, which is our technical reports. And Scott, turn it over to you.
All right, thank you, Colby. All right, get it going here.
Okay. God, I think I can see you, but I don't see I see your screen.
Can't hear, can you hear anything, Colby?
No, I can't hear anything.
Oh, that's too bad. I don't know why it's not working.
Scott, we can see your screen. We just saw the files, but we didn't see anything else.
Oh. Can't see that?
Now we can see it, yes.
Let me start over. There we go. I pre-recorded it.
Oh, and then Scott, can you stop real quick? You have to click on options where you share computer sound because we can't hear it.
Oh, I thought I'd done that. Let's see here. Okay, let's see here. Sorry. Can you hear me talk?
Yes, we can hear you talk. Yes.
Well, maybe I'll just give it anyway. Just talking. I don't know where the computer sound option is. So.
Yeah, it's before you share your screen. There's options on the bottom, but if you want to go ahead and just talk through it, it's fine.
All right, I'll just do that thing. Let me see here. Let me get rid of this. All right, let's see here. Oops. All right. Well, now it's just going. Well, shoot. It's just doing this. Keeps playing. Sorry, you guys. Okay. Well, that was.
So Scott, let's try this again. Let's try this. So go ahead and share your screen, and a window pops up, right? You pick whatever desktop screen share you want to hit.
Yeah.
On the bottom of that window, you see the options where you say computer sound and optimize video share clip. Do you see those options?
Okay. Just a second here. All right. Share screen. Oh, I see. Yeah, I see them.
Okay, yeah. Right. If you select those options, then we can hear your pre-recording video.
Okay, thanks. Sorry, didn't see those. Didn't see those options.
In a few places across the West, as we...
Yep, we can hear it. So you want to go ahead and restart from the beginning then.
All right, here we go.
Yeah, you stopped your share screen.
Yeah. All right, let's start this again.
Hello, everyone. My name is Scott Woodall, and I am with the NRCS Soil and Plant Science Division out of Phoenix.
That worked.
And I will be giving a report on the update of Ag Handbook 296 for the West region. First of all, a brief background of what and why of Ag Handbook 296. The handbook defines the two most upper subdivisions of the land resource area hierarchy. The land resource area hierarchy is the NRCS's system for landscape classification and categorization. It is essentially a taxonomy of spatial subdivision from the land resource region subdivision to the component ecological site subdivision. All spatial units fit within the broader range of characteristics which defines its umbrella subdivision. For instance, all of the ecological sites and soil components within an LRU fall under the range of characteristics of that LRU. Soil and ecological site update work is also a top-down, bottom-up process. As we move forward from political boundaries to ecological boundaries by which to update our soil and ecological site information, we need to fully define our central concepts and boundary criteria of our larger subdivisions, which is what the Ag Handbook 296 update is striving to do. The national team that has worked on the update has made strides to provide a comprehensive narrative of the top two subdivisions of the land resource area hierarchy. These are our land resource regions, or LRRs, and our MLRAs, our major land resource areas. These narratives that the team has written includes, first, a central theme, and second, boundary criteria. Specific criteria for boundaries is developed by using the overarching guidance of the central theme. Secondly, a generalized land resource area map showing LRRs and MLRAs will be included in the handbook at a scale of 1 to 5 million. This map was developed using the central theme and boundary concepts as guidance. The process, or the timeline of developing the handbook, updating the handbook, began in 2015 when central concepts and boundary criteria were worked on iteratively using tours, workshops, and teleconferences. This was followed by working on the generalized map. Map formation continued as an iterative process, working with multiple NRCS groups and agency partners. Narratives for central concepts and maps were discussed and displayed at previous NCSS conferences such as Boise and Tucson. We are currently finalizing the editing of the narratives and hope for publication within the next 4 to 6 months of the handbook. This slide is an example of our generalized map that we created from our MLRA concepts. At 1 to 5 million, the line work has been smoothed as to not reflect a false sense of on-the-ground accuracy. In a few places across the West, as we have made strides to better define our MLRAs, we have made adjustments to our concepts and maps. I will now share a few of our more significant concept changes. The first is with MLRA 28A. It is currently called the Great Salt Lake Area. We believe that a name should reflect the central concept, so we are changing the name to Ancient Lake Bonneville. This better reflects the extent of the MLRA, and we can better develop boundary criteria based on the basins and ranges which were influenced by Ancient Lake Bonneville, of which the Great Salt Lake is just a remnant. We are planning to merge MLRA 31 into MLRA 40. These two MLRAs are both Sonoran Desert Basin and Range concepts, but were separated by the California and Arizona state boundary. We feel that by removing the political boundary, we have gained flexibility to handle local uniqueness at the LRU subdivision level. With the Mogollon Rim, we have kept both MLRA 38 and 39, but we have improved our concepts and definitions. MLRA 38 is more specifically mixed geologies below the Mogollon Rim, and MLRA 39 is defined by landforms and that are associated with volcanic geology above the Mogollon Rim, and it is situated on the southern portion of the Colorado Plateau. The diversity of MLRA 42 was studied and discussed for a few years, and it was eventually agreed upon that MLRA 42 should be split. 42A will become the Trans-Pecos Mountains, Plateaus, and Basins, and 42B will be the Southern Rio Grande Rift. Alaska is planning to merge MLRA 235 into 225 as these coastal zone MLRAs are defined by similar elements such as geology and climate. Alaska also plans on merging MLRA 221, the Kodiak and associated islands, into other coastal MLRAs 220 and 225, as elements such as coastal landforms, geology, and climate are similar. Other Soil and Plant Science Division regions in the West, regions 1, 2, and 4, have made minor changes to bring clarity and have also worked on central themes and boundary concepts in their narratives. But they have no significant changes where MLRAs have been added or merged. In the future, like all things ecological, we believe that continued development of our land resource area hierarchy is a dynamic process. We intend to keep building on our LRR, MLRA, and LRU concepts as we work on future soil and ecological site projects. Here are the points of contact for the national team who services the West throughout this project. Curtis Monger is our national team leader on the handbook update, and he's with the National Soil Survey Center. Chad Ferguson is also with the National Soil Survey Center. Jane Karanen is with Region 4, Mike Regan with Region 1, Kendra Mosley with Region 2, Tim Reedy with Region 13, and myself, Scott Woodall, with Region 8. So I want to thank all the partners and participants and all of you who have helped make this project possible, helped us with the iterative process that we've worked through, and I look forward to an updated Ag Handbook 296 to help us in the future. Thank you.
Okay, thank you, Scott.
Let me know when it's time, Colby.
Yep, you're good. I can see and I can hear you. You're good.
Wonderful. All right. I'll try and keep this quick. Hi, everyone. My name is Dylan Bodette at the Soil Survey Center in Lincoln, Nebraska. I'm giving this presentation largely for everyone else listed here. Jason Nemechek, previously the state soil scientist for Wisconsin. Adolfo Diaz, also on the national staff. And Henry Ferguson, who used to be on the national staff, now retired. But the data that are available, and then I'm going to be quickly demonstrating, discussing here, this was largely his vision, kind of an updated approach to delivering our incredibly complicated laboratory characterization data in a way that was really conducive to exploration and data analysis. So anyways, a lot of people involved, and this represents kind of a progression of ideas and philosophy over the last 20 years. Let's see if I can get my slides to, there we are. Like I said, a lot of people involved here. Henry Ferguson, longtime NRCS employee. Rick Nesser, he just retired, but he has been our, basically our laboratory information system and the Lab Data Mart website administrator, programmer. Really, Rick was responsible for marshaling all of the data from the characterization step, so our national lab, on through into different database products. Jason Nemechek and Adolfo Diaz largely responsible for automating the reshaping, reformatting, and delivery of these new snapshots and the web service that we are working on. Clearly, none of this would be possible without the Kellogg Soil Survey Laboratory staff who do the actual difficult work of characterizing the data. And clearly, anything that we deliver builds on over 100 years of cooperative effort. So I think that's always important to say. Previously, you may have been familiar, you may have used some of these different interfaces or products. Oftentimes, if a cooperator or somebody needed a very specific set of laboratory data, they'd call Henry Ferguson, they'd call Rick Nestor, they'd call somebody in Lincoln and say, hey, can you get me this? A custom report would be submitted, and eventually you'd get the data back, usually as a pile of text files, which often that's enough to get the job done. Rick Nestor put together an annual Microsoft Access snapshot that's been available, but I might say not very well advertised for a long time. This was one of those things that typically you would need to call up Henry, call up Rick, or call someone in Lincoln and ask for this snapshot. Not a lot of people use that other than power users or folks working at the national scale. The NCSS lab tables have been available at NASA's for a number of years for NRCS employees, not that useful for cooperators. And then the SoilWeb KSSL web service, accessible in R, has kind of been our stopgap Band-Aid approach to a web service interface to our laboratory data. That's not going away, but now we have a new option through Soil Data Access. And then I just want to mention that what I'm talking about now doesn't replace, supersede, or in any way contradict the information and interface to these these data through the Lab Data Mart. That's still kind of the official launch pad for our national characterization database. Okay, quickly, we have a number of new KSSL snapshots. Like I said, these do replace the previous Microsoft Access versions of the data. The file structure is completely different. The table structure is completely different. The column names are different. This is an entirely new beast. These will be generated on kind of a semi-automated refresh, I'd say at least at a monthly interval, possibly 2 times a month. The data don't change that frequently. There's usually big batches of data that get pushed through the lab and eventually end up in the database. So we're trying to strike a balance between efficiency and keeping this thing up to date. But at the very least, I would expect monthly updates. We're offering the data in a couple of different formats. We have SQLite, which if you've never heard of it, well, now's a good time to hear about it because almost everything we do on our mobile phones and our web browsers, those are all built on SQLite databases that are kind of abstracted away behind interfaces on your iPhone or on your Android phone. It's a compact, efficient, open source, file-based database that can perform like a relational database. not quite as efficient, but for the number of records in our KSSL snapshot, it's plenty efficient to push around millions of records in fractions of a second. For the work that I do, this is my primary snapshot. This is the one I prefer to use. Not everybody has the same workflow or the same needs. So we also have an ESRI file geodatabase. Some folks prefer to do all of their work in ArcGIS or ArcPro. That's a good place to use this version of the same snapshot. And as long as our 32-bit Microsoft Access drivers continue to work, we will produce a Microsoft Access snapshot for those folks who are either tied to that style of workflow or just prefer to work in that environment. There's no guarantee on how long that's going to last. Contact Microsoft if that's a problem. It's kind of out of our hands. Like I said, there's a new table structure and also some morphologic data from NASA's, color, structure, roots, rock fragments, all that good stuff. This is a little screenshot of what you find at this link here. This isn't nationally advertised. It's kind of a difficult link to work with. We'll probably be moving these somewhere a little bit more stable in the near future. But contact us if you have any questions. Very quickly, soil data access. If you don't mind, please maybe type yes or no in the chat window. I'm really curious how many folks here are using soil data access. And hopefully this is old news. But just in case, I wanted to mention that this is kind of our SQL interface, low-level interface to Surgo, StatsGo, and now the KSSL laboratory characterization data. This may solve 90% of the questions that you have related to soil survey data, as long as it can fit within the record limits. There's a real simple, what's called a REST post style interface that can be submitted from all kinds of different libraries, R, Python, JavaScript, you name it. There's a library that supports this. The data are returned as JavaScript object notation or JSON text documents that pretty much any language or library can parse these data. And it's fully indexed, running on high performance machines, and so you can send a request and get it back usually in under a second. As long as your request can fit within the 100,000 record limit or a 32 megabyte JSON file, this may be a solution for your questions or for your problems. Otherwise, it's not a replacement for a local copy of the data, either GSurgo or the traditional Surgo archives. And as you can see, the popularity of SDA has increased dramatically over the last couple of years. These are millions of requests per year. Whereas it's not to say that this is necessarily more popular than Web Soil Survey, but we're finding that various institutions, private consultants, all number of customers we didn't even know we have are hitting SDA at a kind of a tremendous rate. So what does that look like? SDA may be for you if you're happy or if you're comfortable writing queries using SQL. With some of the documentation out there, some of the tutorials available, this might be fine. But basically you compose field names, you describe tables that you're targeting, you describe join conditions, filtering, you could even describe spatial queries. In this case, I'm asking for basic soil morphology, physical and chemical properties associated with those components overlapping or intersecting with this WGS84 coordinate pair. The KSSL data as accessible through SDA, it's the same idea. There's an SQL interface, I'll say roughly the same table structure and linkages as the snapshots. This is still kind of a work in progress, so I just realized that not all the names are identical. We'll fix that. You can connect these things up using now you can connect the KSSL data directly to Surgo and StatsGo as part of your SQL statement, just using simple joins. Those joins could be spatial, they could be taxon names, matching component names. There's lots of different ways you can mix and match these data. Again, it has to fit within the constraints of SDA, the 100K record limit, or the 32 megabyte resulting JSON file size. You can do a lot within these constraints. And if you can't, you can always chunk up your request into small pieces and typically get your answer just as fast. What's different? Like I said, there's a simplified table structure. Suites of related data are combined into relatively wide tables compared to the previous snapshots. So in the table of physical soil properties, there are about 75 columns. Well, only half of those are actual data. The other half are associated method codes. I'll explain what that means in just a second. Basically, for any given, say for particle size analysis, for the sand, silt, and clay percentages that are given in the physical properties table, each record, okay, so each soil layer that was sampled and characterized, I say layer because sometimes subsets of a horizon are sampled and characterized. So for each soil layer sampled and characterized, there is a sand, silt, and clay percentage, and then a whole host of different possible method codes. This means that we are layering up some of the different methods, which depending on what you want to do with the data, it may mean that there are methods that you might find incompatible that have been combined together into a single table. You can use the method code to then filter out those records that you don't think are suitable. So for example, if you don't think the hydrometer is sufficiently accurate for the analysis or the question that you have, you can filter those out using the method code. Okay, well, we have the data are available, and well, it's not very well documented yet, and I'll take some of the blame for that. But needless to say, there's a couple suites of different tables: glass counts, geochemical, chemical calculations. These are derived properties. We've got our X-ray and thermal data, our estimated hydrologic parameters, hydraulic parameters. Anyways, all of these tables are connected together using indexed table keys, which will be in the documentation. So stay tuned for that. Okay, appreciate your attention. I just want to emphasize that these are a work in progress, and we should have documentation with worked examples very soon. We always appreciate feedback, and I would hope that you'd contact Jason Adolfo or myself if you have any questions, comments, or suggestions. Thanks a lot.
Thank you, Dylan. Very interesting. Lots of work you've done. Thank you. So, our next presenter is Dr. Mark Stolt.
See.
Mark, we can hear you.
All right, can you see my screen?
Yes.
All
So
right.
you just need to go up to the top and start playing. So.
Oh no, I shouldn't start the video. All right, everybody can see me?
Yes, we can.
All right, great. Sorry for a little confusion. All right, thanks for tuning in this afternoon. Today I'm going to talk real briefly about wet soil order and soil taxonomy. This is the work from the International Committee on Subaqueous and Aquatic Soils. Over the past 5 or 6 years, there's been a lot of interest in making fundamental changes to soil taxonomy, and some of these you may be aware of. It's really a result of this big expanse in soil taxonomy over the years. You can sort of see the 1983 first version of the keys and what it looked like in 1996. So there's been a lot of taxa that's added, but really no one has looked at the bigger picture and how to sort of make some fundamental changes to make it a little bit easier to classify the soil, especially for newcomers, and for us to sort of better grasp of the information that's provided in the classification. To sort of illustrate this, you can see the increase in subgroups and insectisols between 1975 and 2010. We started with over 150 and more than doubled that over that period of time. To sort of get a handle on this, As soil taxonomy went from this basic system to something that's quite complicated, this illustrated guide to soil taxonomy was developed. Originally, it was called the Simplified Guide, but no one really liked that term. It sounded like we were trying to dumb down soil taxonomy and make sure that you sort of recognize that all these fundamental changes, that's the last thing that we're really trying to do. Is what we're trying to do is improve the system, but give you the same amount of information. The illustrated guide has a lot of positive aspects to it. It's mostly used for college level students, and it's helpful in explaining some of the soil genesis and descriptions and so forth of the various horizons and things like that. But there are some issues. One thing, it only classifies to the grade group level. So we're teaching our college level students that are then coming into the workforce how to classify soil to the grade group level. Most of our soils information is at a much finer level, series level, it's mapped. And so the students really don't understand family level and even subgroup. Only 90% of the classifications end up to be correct, so you can't really use it all the time to get the correct classification. And if you think about it, the grade group level, there's a lot of what we call garbage can taxa, such as distrodepts and haplostauphs. There's just some examples of, it really doesn't tell you very much if you're interested in use and management of that soil. And so this classification is sort of not very helpful for applications. In 2015, the Soil Science Society established this task force to develop fundamental changes in soil taxonomy. Essentially, there was two main objectives: to make this system more efficient and useful for the soil science community, and also to serve as an effective and engaging tool for that community and to reach other disciplines and communities that use soils information. We want other folks to use soil taxonomy. These are some of the soil taxonomy issues that were addressed by the task force. The one that I'm talking about today is at the bottom. I also included creating a soil order for anthropogenic soils. It wasn't a charge of this task force, but it was a consequence of our efforts. And you've probably heard something about the anthropogenic soil order. And so I wanted to just mention that. These are the members that are on the task force. David Lindbo and Marty Ravenhorst were charged with essentially coming up with an initial version of the proposal for the wet soil order. And at the 2016, let's see, here we go, meetings of the Soil Science Society, we had this poster presentation on should there be a wet soil order. And at that meeting, we had a ballot box. Essentially, you could choose whether you thought that we should have a wet soil order or not, and then decide where along the wetness continuum you think that break should be. You can see here, this was the ballot votes for the 40 individuals that participated at those meetings. A couple interesting things here. First is that 95% of the folks thought that we should have a wet soil order. And the other is a wide variety of percentages on where we should make that break. You know, should it be just at the subaqueous? Should it be per aquic and subaqueous and so forth? But to me, the take-home message here is that there's a lot of opinions, but most people think that we should have a wet soil order. So over the next 3 or 4 years, we took this poster and our ideas around to different conferences, Soil Science Society of America meetings, National Cooperative Soil Survey regional and national meetings, and then at various field trips where we talked to folks that are in the field and said, how would you classify this? Do you think a wet soil order is good? And some things like that. And so there was a lot of discussion about this wet soil order over the past 3 or 4 years. Last year, we started to work as this International Committee on Subaqueous and Aquic Soils, ICMSAS. These are the members that are on that committee. Marty Ravenhorst is probably the best or most well-known wetland soil scientist in the US and probably worldwide. Everybody knows David. Joe Parsley was the Soil Taxonomy Focus Group Chair. Jim Thompson worked on wet mollisols for his PhD. Matt Ricker is a fairly new a faculty member at NC State, but over the last 10 years, he's been looking at alluvial soils, riparian zone soils, soils that have formed along rivers and streams. Peter Shad and Corny Van Hoysten, these are the first and second authors on the WRB, the World Reference-Based International Soil Classification System. Rob Fitzpatrick was the main author on the Australian classification system. And then Curtis serves as sort of the moderator, arbitrator, or arbiter for the committee. So last summer, about a year ago, we met for a week and sort of hashed out most of the original proposal. We went to the field an afternoon and then for a full day and looked at a range of different wet soils and started to see how they fit within the classification system, what was missing, what we needed to essentially address, and some things like that. We had many sort of meetings over basically emails and things like that to further develop the system. And then in November, we met for a whole day again to hash out some of the great groups and subgroups for the classification system. And then over 3 or 4 months after that meeting, actually longer than that, we tried to develop the classification system in its entirety and come up with examples of fine soil series that meet the new criteria for the classification system. If you go to this web page, the National Cooperative Soil Survey Regional Conference web page, you'll see there that there's the regional standards and taxonomy committee proposals, and you can go there and see the proposal itself. And I encourage you to look at that proposal and then send comments to me or to Mike Reagan, the soil taxonomy chair there for your region, and he will get those comments to me. The new soil order would be called aquasols. The formative element would be AQ. And essentially we're talking about a wet soil is one that the water table comes to the soil surface and stays there long enough to basically severely alter the soil morphology and impact the use and management of those soils. And pretty much what we mean by this is that you have aqua conditions within 30 centimeters of the soil surface or less. Under the proposed keys to soil orders, if you have the anthropogenic soils, that would classify out first, then the gelisols, then the histosols, and aquasols. So these would be just for mineral wet soils. The histosols would classify out first. These are the keys to the suborders. You have the Wasatchs, which are the subaqueous soils, the Perax, the ones that have peraquic moisture regime, Leptax that have a root restrictive layer within a meter, Verdax, those that have vertic soil properties, Humax, the ones that have histic, malic, melanic, or umbric epipetons, the sandy ones, the Somax, ones that have an argillic horizon, the Arjax, and then the Orthax would be the default that didn't classify into any of the first 7. There are great groups and there are subgroups for all of these orders within the proposal. So again, please look that over. I just wanted to give you an example of the great groups for the PERAC, and then I'll also show you some subgroups for the PERAC. So for the PERAC, again, these are the ones that have a peraquic moisture regime. You have those that have a sulfuric horizon, those that have sulfitic materials, those that are saline, those that have fluid materials are what we used to call high N value materials, those that have a histic, malic, umbric, or melanic epipeton, the sandy PERACs, the ones that have an irregular decrease in organic carbon, and then the haploperacs. These are examples of subgroups for the sulfiperacs. And what you'll notice here is after the criteria, in broad and in parenthesis, in bold, I mean, and in parenthesis, you'll see some of the series names. So this broad kill that you see for the sulfiperac or matunic for the histic, one with histic epipeton, these are series that meet the criteria for the sulfiperacs. And so not all the classifications at the subgroup level did we find examples that are currently a soil series. That doesn't mean they don't exist. It just means that in our search, we weren't able to find all of those. So what can you do? First, as I mentioned before, please send me any comments that you have on this proposal. But specifically, it would be very helpful if you could essentially look through this proposal and see if there's any soils that you're familiar with, wet soils that you're familiar with that were left out of the classification. And that if you could let us know so that we can make sure that we include those. Also, some of the subgroups, it's possible that they don't exist. We put the classification system together thinking that these are all the components that we need to have, but it's possible that some of them have those components, but it just doesn't, they don't exist. And we know there's lots of taxa out there that we don't have any series for right now. It doesn't mean they don't exist, but right now we don't have examples. So you can send those comments to me, or you can send them to your soil taxonomy chair, Mike Reagan, and I'm sure Mike will get those to me. So I tried to talk as fast as I could to get in my 10 minutes. So hopefully, hopefully I didn't take any more time than I was allotted. Thank you very much.
Thank you, Mark. Our next presenter is Sean Neild. Sean. Hey, Sean.
And now hopefully you can hear me.
Yes.
Okay. And we'll see if I can get my presentation up there. Did that work?
I'm not seeing anything yet.
John, if you scroll down to the bottom of Zoom, you'll see a green button where it says share screen. Do you see a green button?
Yeah.
Okay. You'll click on that, and then you either, if you have a dual monitor, you pick what screen you want to share. And if you
Yeah,
have
I did.
Okay, and then you should double click on it or hit that blue share button, and then we should see it. There you go.
Okay, I think that's all it needed.
Yep. And now there you go. Perfect. Now we can see your presentation. You're good.
Okay, excellent. First of all, I want to say thanks to Colby for squeezing me in here. This isn't terribly technical, but it's a good story to share. My name's Sean Neild. I'm the state soil scientist for NRCS Idaho. And I'm going to be talking to you today about the Digital Idaho Soils Atlas. And I think one of the ways to maintain our relevancy as we move forward is to increase the utilization of soils information. And so we hope that this project generates interest in soil science outside of our typical land management and agricultural user groups. I'm going to talk about how we've taken a print publication and reimagined its utility as a reference and educational tool by adding some interactive features and additional content through an ArcGIS story map. And I should say, before I continue, that I worked on this with Shauna Bernal Fields, and while I may have had a lot of the initial ideas on instigating this project, she's the one who's done the lion's share of the work here. So. The original publication is really visually rich. I even think of it as kind of like a coffee table book almost with a real technical bent. It features 54 soils from all over Idaho. For each soil, there's a pit photo. They're fantastic. They're immaculate. The pits are all immaculate. The lighting's perfect. And there's an associated landscape photo. They give horizon descriptions, and then a discussion of prominent physical and chemical characteristics that affect use and management. And even better, it was a cooperative effort between NRCS, or what was then SCS, and University of Idaho, the Forest Service, BLM, Bureau of Reclamation, and the Idaho Soil and Water Conservation Commission. Here's what the original publication looks like, and I just screenshotted some of the landscape and pit photos there for you too. It's out of print. It was published in 1983. Paul McDaniel gave me a pristine copy of this when I first started in this position. And it covers everything from ash cap soils of the forest to the Torrey Orthon to the Snake River Plain that are used for ag. We discovered that the associated soil samples, the soil samples that were taken when those pits were excavated, were available. They were around. We had a storage facility at University of Idaho that we've been storing box samples and manuscripts in, and that space was going away, and everything needed to go somewhere. And in looking through all those box samples and getting them out to the different soil survey offices that could use it for reference, we found the Soils Atlas samples. So with some assistance from the local MLRA leader, Brian Gardner, and support from the National Center, thank you, David Hoover, the samples were boxed up, shipped to Lincoln and analyzed. That data has been made available now. So it serves as an additional reference for ongoing soil surveys and other soils investigations around the state, which is awesome. But we looked at that and I thought, this really should be used as a way to breathe some additional life into that publication that I like so much. So I got this idea that, well, let's use a story map to share this information out and utilize. We have high resolution scans of the pit and landscape photos from the Soil Atlas. So I suggested a story map, asked Shauna to look into it, and in no time we seemed to be able to cobble together something that we think is useful. We went back and forth editing this quite a bit. I helped with the narratives, and Shauna got the data loaded. It has lots of functions and features. The front end of it, there's a primer on soil forming factors, soil functions, and soil health, just with a brief narrative, so that for the uninitiated, there's that. And then each one of those things has additional links for deeper reference if folks want to do that. And then you get into the tour of the soils around the state. So there's the original soil and landscape photos. There's interactive maps. There's an overall map for all of the points. There's tighter scale maps for each individual series, and embedded websites for each one. And I'll just show you some of these features. So here's the overall map. It shows all the points around the state. If you hover over a point, it opens up a landscape photo indicative of the landscape that the series lives in. And this is from the Soil Atlas. It also brings up all of the points that are available, list them in alphabetical order. As you move down through the story map, oh, I forgot to mention something here. No, there it is, right there. In the with that photo that you see there and the series name underneath, that's the taxonomic classification. If you click on that, it opens up the OSD. There's the pit photos, and with the pit photos, directly under all of those are discussion of prominent characteristics, how they affect use and management. Also, for each series is an embedded hillshade map with landform callouts. Also, with each series is the series extent tool with that series name already loaded. So you just click on the box and boom, the series extent map pops up. So, and for folks that want to get technical, the lab data that was recently run, we've got that posted. And for instance, University of Idaho is already interested in looking at this for their pedology class. If you wanted to look into the lab data and see how they arrived at their classification, and oftentimes those will differ from what you might see posted for, say, the OSD. We won't get into that discussion here, but this can be useful. You can get very technical with the lab data. We put some additional information after you get through all of the series, and there's 32 soils that have all of those maps and photos and information. And we give the soil atlas, there's images of that, and the acknowledgments page. There's a brief discussion and link to Web Soil Survey and the Kellogg Soil Survey Laboratory and our contact info. And this was surprisingly easy to put together. Of course, I say that, and Shauna, like I said, Shauna did most of the work, but really, I mean, we've got an organizational account with ArcGIS, but there's a public account, which I understand you can use as well and author one of these. You provide the creativity, the photo, inset maps, narrative, and toss it back and forth between a group of people to review it. And then when you're ready, you go public and share that with the world if you want to. So that's what we did, and I'm going to share that link with everybody. And I hope that you all enjoy it. Thank you very much.
Thank you, Sean. Okay. Well, that concludes the technical portion of our, the technical portion of our presenters. We'll now open it up. We have several questions that came in. The first few questions were for Scott Whittle. I'm going to go ahead and stop sharing my video. Scott, the first question was, will the data and the narratives for the final MLRA updates be available in a database?
Hi, Colby. Will they be? Well, that's a good question. We are working on a hardbound publication for Ag Handbook 296 for LRR and MLRA description. We know that that's not a flexible thing for future work. And so we hope that, well, Ecosystem Dynamics Committee has an ongoing recommendation to actually create a catalog for MLRAs and a catalog for LRUs in EDIT, where we can continue to constantly expand our definitions and concepts of our hierarchical subdivisions. So possibly that may be our database in the future for this information.
Would be the EDIT database, potentially?
Yeah,
okay.
Potentially. That's a thought that we're recommending.
The other question for you is, will LRUs be a mappable concept in this update?
Not in this update. We only covered the LRR and MLRA concepts. I know Curtis Monger has kind of kicked around a possible another publication for LRUs. I don't know if we ever will, but again, we hope that we can expand the EDIT database to have that information as well. That's kind of our recommendation.
Okay, thank you.
Thank you.
There wasn't, for Dylan, there weren't any particular questions, but there was a large amount of information about SDA libraries presented in the chat window. So if you have questions about SDA libraries or from Dylan's presentation, I encourage you to look at the ongoing discussion in the chat window. There were two questions for Dr. Mark Stolt. The first question was, how is this proposal going to simplify the keys to soil taxonomy? Why not just separate out coastal and subaqueous soils?
I will first just mention that I really didn't have time to sort of talk about the advantages of creating a wet soil order. In the beginning of the proposal, there is an introduction that's more, maybe 4 or 5 paragraphs long, that sort of explains the advantages and some of the reasons for possibly coming up with a wet soil order. How is it going to simplify the keys? So there's a lot of reasons, and I won't go over all of them, but most of the ones that would classify out as a wet soil order as an aquasoil would probably be considered hydric soils. The idea is not to match up one-to-one aquasoils with hydric soils. That's not the idea. Soil classification, soil taxonomy is for many uses, as opposed to a hydric soil is just a part of whether it's a jurisdictional wetland or not, one of the 3 parameters. But a lot of soils science right now is about wetlands and things like that. And so this is really a part of our language that's really been a part, important part over the last 30, maybe 35 years. And so it's like we're behind the times on that. All the other classification systems have at the highest level the wet soil orders that are, or the wet soils that are identified out first. I think it would be important for many people that practice as wetland scientists that are doing wetland delineations. They could use our classification system and recognize that, hey, this is an aquasol, so the chances are that's going to be a hydric soil is very high. So right from the beginning, they can use our classification system at the highest level for their assistance. And a lot of people that are ecologists and things like that could use it for other purposes, but essentially to address a certain environmental conditions.
Okay. 2 other questions. The first of which is, how do we deal with drained soil situations? Is that an automatic order change?
No, I think what you're going to do is recognize, for the most part, by the morphologies, that this is an aquasol, a wet soil. And if it's been drained, I think that would be a part of the mapping. It'd be a phase, not a part of the classification. So if you drain it, my experience with drained soils is it still has the same morphology as we originally had, unless it's sort of borderline. And so I think you'll recognize that it was drained. So I think it should be a phase, not a part of the classification.
Okay. And then there was another question for you about what is the timeline of this proposal? And if it's accepted, when would we start teaching it as an accepted soil order?
Well, that's a really good question. I think Curtis Monger and Dave Lindbow, they have some ideas about when we would have the next addition to soil taxonomy. And hopefully this and the anthropogenic soils would be within that addition. So, 3 years, 4 years, something like that. I think, at a maximum, hopefully within that amount of time, we could start teaching that and it'd be a part of our classification system.
Okay. Well, thank you. Those were the questions that had been posted.
All right, thank you.
So thank you. And then Sean, there was a question that came in for you about the taxonomic classification. Are they the updated or are they the original?
Those are based on the OSD classifications.
Okay. I encourage everybody also to look at the group chat for more information on Sean's presentation. There was a few links shared there as well about at least the Washington Soil Atlas that I saw. So, alrighty. Well, that concludes our technical report session. We'll now move on to session 6, which is our committee reports and our business meeting. Our first committee report is from the Technology Committee.
Hi, Colby. This is Amy.
Hi.
Let's see, let me share my screen. Just put in some notes up, nothing fancy. So to give those who didn't participate a little summary of what we did, we actually held a pre-meeting to kind of get a lot of the old business out of the way with status updates and identify discussion topics that we'd focus on since time was limited this year. with this with the virtual meeting. So during our actual meeting, we talked a lot about kind of the committee purpose and function, and kind of what the interaction would look like with the focus teams, the frequency of meetings. Currently, it seems that it's only every 2 years when we have these regional meetings, and then discussion about interacting with other regional technology teams. We did a technology update. There's been a lot of new staff in NRCS, as well as partner projects that are going on, so we discussed those. Some of the different topics that came up for new business or technology included some discussion about TUI, TESPI, which is the Triangulated Ecological Site Potential Index. That was kind of new to many of us. And talked about some in-field technology and tools with the PXRF, as well as the need for maybe having some in-field measurements to support in-field soil health assessment. The need for soil health data-driven products from GSurgo and Surgo data. I know there are some interpretations currently, but perhaps there's a need as we do more and more soil health to make sure that our soil survey data is being utilized. Updates on soil data viewer. It sounds like it's in the works, but it may take a little while before a new update's available, as well as mobile data collection. For our next steps, we decided that it makes most sense to schedule a meeting with all the other regional applied technology committee chairs to kind of see what everyone's doing, how people are interacting, and then try to establish our applied technology committee for the West region via just starting with an email distribution list and then a survey to kind of determine meeting frequency and topics, interest. And then we did identify one topic that we would bring as the Western Region Applied Technology Committee to the NCSS next year, and that would be the need for soil health data-driven products and in-field assessment tools. And that's all I got.
Okay, thank you. Are there any, I don't anticipate any, but if there are there any questions about the technology committee? Wait about a minute or so. Okay, seeing no questions, we'll move on to the next presenter, Dr. Cynthia Stiles, for the research committee.
Okay. Hello, everyone. I'm going to share my screen here as soon as I can find my presentation. Okay. Oh my goodness. Okay. Oh. Sorry, technical difficulties.
Not a problem.
Okay. Because I can't run one thing off of another. Here we go. Okay. Let me see if I can get this right. Okay, I'm going to share this screen. All right. And I'm going to put the presentation up. Can you see this presentation now?
No, I can't.
Oh,
Cynthia, on your on the Zoom, do you see a green button that says share screen?
yes, I'm trying to do that, but unfortunately I don't have very many screens, so I can't do everything here. Sorry, trying to get this to work. Is that showing?
Yes, we see it now.
Oh, yay.
We're good now.
Victory. Okay, now I need to get rid of this thing. Okay, so hello everyone. Sorry about the technical little glitch there, but here we're ready to go. I know that my glasses are kind of obnoxious there, so I either have to wear them or not. The meeting convened with our virtual meeting. We had several attendees, probably up to about 18, representing the Forest Service, BLM, NRCS, and several universities. The focus of the meeting was to review primary research topics from the previous West Region Conference and to develop a short list of focus research topics to allow the members to vote in a flash poll. These cooperative research topics are developed with emphasis on Western ecosystems. The results of the flash poll were used to prioritize those topics and pick a top issue to advance for potential future research funding. In the 2018 regional meeting, the ideas by rank were DUST, which was the top ranked project with the current funded projects in place, soil health, permafrost, data delivery, citizen science, and ecological scales. The priorities of the NRCS SPSD work going forward, right now what we're looking at is soil health gaps, dynamic soil survey with emphasis on landscape relationships, edaphic conditions, specific conservation planning and land management needs, human-altered landscapes, subaqueous mapping, and blue and teal carbon projects, ecological resilience and resistance. Oops, too fast. The research topics that our committee discussed in our brief meeting were determined for the poll provided to the larger audience. The top 5 topics were wetlands in the western landscapes, arid mountain ecosystems, human-altered landscapes, carbon sequestration in semi-arid to arid ecosystems, and the impacts of fire. Team members volunteered to write up the summaries of those topics, and then those summaries were provided out through a Google poll facilitated by Dr. Karen Vaughn. Thank you very much, Karen, for running that poll. And the poll of these topics ran for 24 hours to collect opinions. 88 responses were registered for the flash poll. The results were close, indicating that all these topics are considered important. However, fire impacts was the winner for the top priority, I think for obvious reasons. We're all faced with issues dealing with fire. Wetlands, human-altered landscapes, and arid mountain ecosystems tied for the second place, and carbon sequestration in western landscapes was firmly in third. We consider that all these topics can be concatenated with each other under the umbrella of fire impacts because all of them interplay with each other, such that the priority topic for the West Region Cooperative Soil Survey research effort would be proposed to incorporate these interrelationships into the RFP language as research emphasis areas. We had plenty of useful commentary also provided by the poll members to consider as we develop the final proposed language. 2 other important issues were brought up and are considered to be critical to our academic and our agency partners. The first is a request for resources and collaboration to teach soils and soil ecological community landscapes in a virtual classroom setting. There are significant needs from the academic community for collaborative efforts to convey knowledge of the soil's ecological landscapes to students in such a way that they get a meaningful experience out of what we are conveying. This issue has been noted as I am the co-lead for the NRCS SPSD training focus team. I've already brought this issue up several times within our focus team meetings, and we plan on moving it up to a top priority since we've heard this in the NCSS meetings. The second issue was to emphasize the need for broadening diversity in the soil science field, reaching out with research-related opportunities for minorities and underrepresented groups in soils and ecological sciences. The concerns have since been brought up to the leads of the SPSD diversity focus team. We've already gotten some responses for them, and they will continue to consider our efforts in moving towards including more diverse ethnic groups and underrepresented minorities. Oops, sorry. The proposal language for the research effort will continue to be developed. We're not yet done yet. We want to review with our team members over the next couple of weeks and provide that final report into the document for the record. So your opinions are important to me. My email address is provided there And anyone who has more information or more sharing they'd like to do is certainly welcome to contact me at any time. I'd like to thank my co-chair, Dr. Janice Bettinger, and certainly the efforts of Dr. Craig Rasmussen, Karen Vaughn, and Daniel Hermes, and Jim Wigand in the development of these proposed topics and getting language written up. Does anyone have questions for me?
Hi, Cynthia. This is Dave Hoover. I do have a question. Did your group discuss any new funding sources that are out there for research?
That's a great question. It's something that's been on my mind, but we actually did not talk about that very much. We were real busy trying to get just the topics nailed down. So I feel like I've reached out to Jim Wigand with BLM to ask him what he thinks about the effort of combining and getting more funding put together in different pools so that we could make an effort to move things forward, especially on federal lands, because that's often underrepresented and not fully covered, but it offers great research opportunities for our universities. So other members of the team, I would really greatly welcome any further thoughts on that topic.
Thank you.
All right, well, hearing no other additional questions, thank you, Cynthia. We'll now move on to the Ecosystem Dynamics Committee report.
How does that look, Colby?
That looks fine. I can see it and I can hear you.
Okay, that's always a good thing. Okay, Ecosystem Dynamics report. So we talked about a few things in regards to the databases. We first discussed about the NRCS database, and we touched on the new coding for ecological sites that we hope will be incorporated into NRCS shortly. We also talked about and we gave a recommendation as well that the committee feels it's important for people to be able to access the evolution of ecological sites with their linkages to components. So EDIT can currently warehouse legacy sites, but our committee's recommendation is that it recognizes the importance and fully supports a place in NRCS to recognize past linkages to legacy ecological sites. We also touched on the EDIT database. One of the questions we asked is the current ability to put MLRA and LRU information in EDIT enough? We can currently put some information about these hierarchical subdivisions in EDIT, but there were a couple of recommendations that came out of the committee. One is the ability to include images for keys and LRUs. Sometimes images are really helpful when going through a key, whether it's a key to a subdivision or a key of any type, a key to an ecological site, key to an LRU, whatever it may be. So that's a recommendation. And also this is a recommendation, the second one that we actually had last year at the national meeting, and we're going to continue that with this meeting, is for additional catalogs and edits. We currently have a catalog for ecological sites, a catalog for groups. We would also like a catalog for MLRAs and a catalog for LRUs to, as I mentioned earlier, to continue our ability on working and putting those hierarchical concepts together. And also to reduce the redundancy of higher subdivision information that we are currently placing in every ecological site. And that's a pretty redundant process. We discussed about our committee reaching out to the standards committee in regarding this issue. We also talked about the expansion of EDIT as a tool as a repository for quantitative and qualitative data per ecological site concept. This includes observations, photos, sites, development history, etc. We discussed a couple of things. One is we're discussing the ability for EDIT to maybe expand either the support information section or the interpretation section to include qualitative information such as observations and images of ecological events, such as disturbances, conservation practice effects, that sort of qualitative information. And then we talked about the quantitative information. Where's the best place for that? Obviously, NRCS is a part of that sphere of information and data, but the committee wants to recommend that it supports the landscape data commons for managing and linking point data. In addition, we had a bit of a Forest Service update on, in EDIT, we talked about the possibility of a Forest Service catalog and hierarchy. The committee discussed that as a possibility, and we want to continue discussing and considering that idea while also exploring other avenues by which to crosswalk our classification systems. There was also an additional recommendation for EDIT. Viewership of draft and legacy ecological sites has been an issue for people. Currently, draft and legacy sites aren't available for public viewing. Maybe we can set up a better network of people who can give viewership permission. Something we need to keep discussing and talking about. Yeah, and we also gave an update on working the Forest Service and NRCS together. We had a lot of collaborative plans, I know at least here in Region 3 of the Forest Service and in the Southwest, for joint field reviews and collaboration on ecological site development. The COVID and forest fires kind of put a lot of those plans on hold. We hope to be doing more of that in the future together. And the last discussion topic is, how do we promote multi-agency authorship of ecological sites and state transition models and interagency collaboration in the authorship, QA, QC, and QA, QC field review process. So we had some discussion on that. How do we work together with ecological sites? And the BLM mentioned they are organizing at a national level to coordinate ecological site work. And we also discussed that more thought needs to occur regarding how we assign permissions for authorship, QC, and QA for soil and ecological site project areas. For instance, if an MLRA or LRU is mostly on public land, then those managing agencies should have QC and QA responsibilities for that subdivision. And so those were our discussion topics and recommendations that the committee brings forth. And that's my presentation. Thanks, Colby.
Thank you, Scott. We'll have a minute or two for questions if there are any, or clarification. All righty. Well, hearing no questions, Scott, thank you very much. We'll go on to our next committee report, that of the Taxonomy Committee by Mike Regan.
Okay.
We can hear you and we can see your screens. Great.
Okay, all set to go. Okay. So, yeah, my name is Mike Regan. I'm a soil data quality specialist for NRCS in Portland, Oregon here. Chair of this taxonomy committee for the West for this conference. So we had a really robust schedule, a lot of members. It was a great time. I appreciate everybody. Just to run down through the members, we had Andrew, Taylor, Alex, Chris, Philip, James, Dr. Nick Jelensky, Jane, Nori, Trudy, and Carrie. So we had a really great committee, a lot of great discussion. We had, I think, 10 official proposals, and then the Aquasol one that kind of came in at the end. We talked about a little bit, so kind of almost 11 topics to discuss. So that was more than I've ever seen before for this conference. So that was exciting. I don't want to go through every single detail, rehashing all the discussion. I just want to kind of summarize here for the report. Obviously, there's a lot of very involved, very technical, down in the weeds discussion on this committee, and we talked a lot about a lot of that kind of thing. So I do want to also say that for this this year, we had a lot of almost every proposal we had to we actually got to have the authors present the proposal to us on our teleconferences, and that made a big difference as opposed to when I've been involved in this in the past. So that was a really great thing, and I'd just like to thank Curtis Monger for arranging a lot of those speakers to talk to the committee. Thank you very much, Curtis. Okay, so I'm going to jump into the results here. So here, this is the recommendations from the committee, the kind of consensus, or sometimes no consensus on some things. But so there's 10 of them, like I said. So I'm just putting 5 on per slide here. So I'm just going to run through these sort of quickly. The first thing we talked about was the proposal for a tephric epipedon. So obviously, volcanic ejected tephra type material. So this came out of the Southwest. It's a good idea. The conclusion here was to return to the author, but also to set up a working group for the West to broaden the scope of this proposal to include, the Northwest and other areas with tephra. So James will be leading that working group after the conclusion of the conference to further that proposal. So if you want to be part of that, let myself or James Harrigan in Arizona know. We'll get you connected to that working group for sure. Okay, the next one moving right along is the artisols order. This one, I say we're on the fence. It's not so much that we have any concepts of rejection. It's just that, it's a very large proposal. I don't know that we fully, everybody fully had time to, vet every instance in that. So, but for the most part, it looks very logical. We think it's good. About the only discussion that's, was ongoing this week even was about this, the HAZOC materials within that proposal, just due to the safety issues and, and the situation of, in lieu of being able to actually sample or measure soil properties, the concept of using a map, a proxy for something for classification. So that issue, I think, is something that still needs some more discussion. I don't think there's a consensus on it right now. I think that'll be a good discussion for the national committee next year for that conference. So anyway, that's kind of the story there. So then the next one was Densic and other sea horizons. I kind of just summarized the name of this one here, but basically this one had a lot to do with horizon designations with root restrictions or bedrock, and whether they should kind of, correlate to diagnostic horizons and so forth. So this was a lot of great discussion. However, I don't think there's a lot of consensus out there. There are a lot of people that feel one way and a lot of people that feel the other way about how these designations should line up with diagnostic features and taxonomy. I think there's valid reasons both ways in some cases to keep them separate or to combine them. So anyway, I think, you know, this is another thing that this particular proposal, it was more of some questions and asking for some recommendations, not necessarily a cut and dry, here's what I would snip out and replace in taxonomy. So I think there's more discussion warranted on that one. Again, you know, with the national committee, they should, you know, have some further discussion on that. And I also, just as my own personal preference or request for that committee to work on the definition of what is the difference between a sediment and a sedimentary rock. You know, it seems like we get hung up on this label of rock or somebody else's label of rock versus sediments, and what are the property differences. I think that's something worth looking into. Okay, so I'm going to jump into the limnic subgroups for gel-alls. This one, we voted to return to the authors of the committee. There's some concepts in terms of the definitions of limnic materials and the study site that it may not quite fit into, but we have some comments and suggestions that maybe pursue something relative to the unique properties of those sites. And really it was about the large deposits for migratory waterfowl in the cold regions in Alaska. So those are sort of unique. Maybe there's a phosphorus concentration that can be looked at for identifying those as groups of soils in the system. So anyway, let's move on to simplifying the moloch and tenumoloch. We put these together because they're very related. The committee's opinion on that was to reject these. Couple briefly reasons why. There is a portion of that proposal dealing with base saturation and using pH as a surrogate that allows for both a moloch and umbric epipedon to coexist. We didn't really think that was the best thing to have. The other thing was the part about using the thinner molochs, you know, the 18 to 25 centimeter molochs that lie directly over a restrictive feature, like say a lithic contact or whatever. If we got rid of some of the rules there to simplify that there and allowed, you know, or did not allow those deeper soils that had some other horizons between the moloch and lithic or root restrictive contact there to be included, we would lose probably a lot of mollisols in the West. And the impact and where those would go and what kind of groups those would fall into in terms of soils is not really known. So those are a couple of the main reasons there. Okay, let me move on to, oops, I don't want too many. Okay, these are the second batch here of 5. Okay, so definition of organics. We're leaning toward approving this one. I think the one thing is that a lot of the committee members didn't have a lot of experience with the Van Post method of analyzing fiber content, but you know, it seemed logical to us. So I guess, you know, we're in favor of, you know, pushing this proposal toward the national committee for consideration to approve. So the other one, I mean, this is the one, well, let me get down there one second. So tier criteria for organics. This one, you know, we were basically leaning toward approving as well. Just a few comments about, you know, it's very minor issues mainly, but there seems to be a simplification of the 3-tiered system for histosols. So it seems like an easier way to deal with them and standardizes some things. So the committee was generally in favor of that. Okay, the family reaction classes for organics. This one is I think, no problem for the committee. The only thing, again, this is sort of like the artisol issue. It brings in just one little piece there about using non-site property information, the occurrence of, or historical occurrence or whatever you want to call it, of certain plant species occurring on site. So if you were, you know, and basically the author talks about, you know, try to tie the ecology, the acid, really acid versus not quite so acid histosols and their ecology together. So again, that's just another issue. It's just not a traditional thing we've had in taxonomy to use, something that you can't measure in the soil itself for the most part there. So that otherwise, it seems very logical. Okay, then the 9th one there, the thaptohistic subgroups. This one, the committee said we don't really have a lot of experience with this. Seems like it's more of an Eastern thing, is where it came from too. So we didn't have any real problem with it, just a few little comments back to the authors that will be in the report. And then the fluventic and pacic subgroups for gel-alls. This is came from Alaska. And well, it's in regard to Alaska, but I think it came out of the Texas group there. So anyway, at the university. So thank you for that. Yeah, this one seems like a very logical, basically using a mirror of portions of the keys and other situations where fluventic and pacic occur and putting it into the gel-alls where it just wasn't there yet. So even if the extent of this is not widely known, it seems like it has enough potential. The committee was in favor of approving that. Okay, the last thing, like I mentioned, the aquasols, we didn't, consider it as a formal proposal, but we still would like to and talk to Mark about getting some comments back. There weren't a whole lot from the West Committee, to be honest, because I think of the timing and gearing up for the field, maybe COVID, I don't know, but we'll keep thinking about it and working on it. I think there's a lot of good things there for the future, so I appreciate that. And let's see, I think, yeah, that's all I really had to say. So again, thank you everybody for your time. It was a great opportunity for a lot of people to get together and discuss the way down in the weeds type of soil stuff that a lot of us like to sometimes. So appreciate that. One other parting shot of business is if anybody is interested in chairing this committee, being on the committee in the future, please let myself or Curtis Monger know. With that, that's the conclusion of my presentation. Thank you.
Mike, thank you so very much for that very clear report. We'll have a minute or two for any questions.
Hi, Mike. This is Dave. What are your plans for continuation? I mean, you mentioned chairing the committee and you're still on the fence on a few items and you still want to discuss things. What are your plans for continuing on for another year at least?
Well, I mean, this committee meets every other year. So basically what I will do is summarize those comments. And when I say on the fence with something, that what I mean there is, it may not have been 100% slam dunk. There might be just some comments to include in the report to the authors, just, so for their consideration. It's really hard to categorize response to these proposals as one of 3 brief phrases, so I'm trying to avoid that by just sending the report to Curtis Monger, and then hopefully he will distribute it to the authors. And if they have any follow-up questions for me or the committee, be happy to address those. But as far as for next year, I think, once the Curtis forms a national committee for the taxonomy for the conference for 2021, whoever is on that, they'll take these issues and kind of get them toward a more final resolution. Does that answer your question, Dave?
Yeah, I was kind of hoping I'd hear something about that you would continue to have meetings in the West research or West taxonomy committee meetings, as well as with the rest of the committees too, just because I'm sure you'll have other issues that'll come up and you want to keep it alive for a while.
Okay, yeah, I mean, for one, we do have a working group we're setting up for the tephric epipedon concept.
Yeah,
so
that
sure,
was
if
awesome.
anybody wants to jump in on that one, if anybody has any ideas for more groups or whatever, let me know. I'm definitely open for that. So.
Thank you, Mike.
Thanks, Steve.
Are there additional questions?
All right. Well, you all have my email if you think of anything. Thank you very much.
Thank you, Mike. Okay, we will now move on to a very brief business meeting. While we transition to Rick presenting this very brief business meeting, we had a minor technical complication with the student poll earlier, so we will reopen that poll. And I ask that you go ahead and vote once more for that person. When you're done voting, this is something we're learning. Please don't click the X to close the window, or if you have an option that says End Poll, please don't click that button. Just minimize the screen and it will go away. That will help us to be able to see the results from all the results. So. Shortly, that poll will pop up in your screen. I ask you to, there it looks like it's there now. So if you'll go ahead and choose. And then, while that's happening, I'll turn the time over to Rick for a business meeting.
Thank you, Colby. Well, hello, everyone, and thank you for coming to our virtual conference for the first time. And our business meeting is in part going to be short this year because a lot of it I hope that we can handle virtually. And in that, I guess I want to, well, first of all, I'll start off with the committee, the unnamed committee, which was the bylaws committee, which I chair, along with Alex Nato. And bylaws committee findings, ours are very brief. We did go through and adjust the bylaws so that the Pacific Islands and Hawaii were folded into the same entity. And we also set up an order for when the conference will be held. And I will be making that available. And that pretty much was our bylaws committee meeting. And just on when the conference will be held, what we're looking at is Alex is hoping to host up in Montana 2 years from now. And then in the next meeting, Amy will be hosting in Hawaii or somewhere else out in the islands at Amy's choice, of course. And so with that, I'd kind of like to suggest that, you know, normally often when we had our business meeting in person, we'd do an in-person vote, but since we're going all digital now, if the committee chairs would send any findings or recommendations that you feel need to be voted on to me, I will distribute those out to the West region for a vote, and then we will collate votes and publish the results to the rest of the region. If anyone has any objections to that, please speak up. And hearing no one, that's really about all we have for business. Does anyone out there have any comments they'd like to chime in with? Well, nobody's jumping up really fast, so I'm just going to go ahead and say, let's move along and let's just end the business meeting part of the conference and thank everyone for connecting in, and we'll move on. Thank you, Kobe.
Okay, thank you, Rick. That was indeed short and sweet. Thank you very much. We'll now move on to the final session or final portion of our meeting today, and that's the awards session. So we'll turn the time over to Dr. David Linbo.
Kobe, this is David. Do you want me to end the poll now or give a few more minutes?
Go ahead and end it.
Okay. And then let me know when you want to share the results.
Thank you. So,
well,
Dave Limbo,
Colby,
we'll turn the time over to you. Okay.
Fantastic. So Colby, thanks for putting this all together. Rick, that was the best business meeting I have heard in a very long time. So short to the point. I wish all our meetings in DC could be handled as quickly and efficiently as that. So it is my pleasure, though, to not quite end, but be the penultimate speaker here and award Rob Vaughn with the Cooperator of the Year for 2020. Rob is a soil scientist working for the U.S. Forest Service Geospatial Technology and Application Center, which provides leadership in geospatial science for the Forest Service and beyond, and is looking constantly for new technologies. Rob has excelled by working with partners to demonstrate their application in resource management and finding solutions to help decision makers and support agency mission, not only with the Forest Service, but also with his work with us. He's made significant contributions with the Cooperative Soil Survey and digital soil mapping. And again, we are greatly appreciative of that. Some of his work has led to better land management decisions, to working more effectively, and really improving the communications with our partners, interest groups, and with the public. So again, over the last few years, he has been an integral part of progressing the soil survey through his expertise and the cooperation that he can bring in with the Forest Service. A lot of what he has done has led to those technical advancements and enhancements with the DSM property. It's extremely important now to realize what he's been able to do and help us with is working right into our push for a dynamic soil survey. So he will definitely continue, I hope, to be part of that. In the past, he has contributed to the Boundary Waters Canoe Area Wilderness in Minnesota, helping that be a collaborative success across agencies. This is a raster soil product that it really showed how well different groups can work together, and ended up with a raster-based soil information for approximately 1 million acres of managed land. He is also working with the Northwest region on several mapping projects, Bob Marshall Wilderness Area, the Salmon Chalice National Forest, the Payette National Forest, and the Ashley National Forest. So really across the Montana, Idaho, and Utah. His experience working on projects in remote areas has been greatly helpful to get us out there, work safely, develop sampling plans, and provide the information we need for boots on the ground. Beyond his work in the field, he can push an auger as well as push a computer. So he has helped greatly again with the covariates, the modeling, sampling design, and really given us what we need to advance. He is also a member of the Soil and Plant Science Division Digital Soil Mapping Focus Team and works on the Properties Subteam, which is working on a nationwide continuous soil properties project that hopefully will be developing a 30-meter CONUS Landsat covariate stack and combined with the Google Earth Engine resources. So this is moving our project forward quicker than it would without Rob's help. So again, we appreciate that. Rob has also provided training with his knowledge to our staff on the Google Earth Engine, using it for data acquisition and analysis, as well as explaining TUI and the TUI toolkit to us. We need to learn more about it. So Rob, every time you can help us learn about it, again, it is something that we need. So thank you. To conclude, Rob brings his knowledge as a soil scientist combined with skills in remote sensing, GIS, big data processing, digital mapping to every project. He is innovative, capable of balancing the need for innovation and investigation to get the job done. Not afraid to do something different, make mistakes, but always move us forward. So again, Rob, thank you and congratulations for the award for this year. And I apologize, I wish we could do this in person, but hopefully this is the next best thing. So thank you very much.
Congratulations, Rob. That's wonderful. Dave, thank you for presenting that award.
You're welcome.
All right. Well, now turn to the very last portion of our meeting today. That's the student presentations, the award for the best student presentations. And congratulations to everybody. Chelsea and Jaylene both were equally recognized or equally voted on, each with 35% of the participants in the poll said that your presentation was the best. So thank you very much. And congratulations to Rob and to Chelsea and Jaylene. Chelsea and Jaylene, I'll be in contact with you shortly. Thank you also very much for participating in this virtual conference. This has been an opportunity, I think, to take a different approach to conference attendance. And I appreciate all of the effort that you've put into participating in this and making this conference happen and to what it's been. So thank you all very much. And that concludes our conference. We'll see you at the national meeting next year.
Thank you, Colby.
You're welcome.